Well, hello everyone, this is KP the Math G getting ready to do another video. It's been a few days since I've done my last video, and I want to say I thank you for those who are subscribing to my channel. I say sometimes it's not about me, but if you want to get back to this channel, I understand. If you subscribe to it, you can get back to it easier. That's what I'm guessing anyway. Let's look at this lesson here. We've been talking about the big three in AP Calculus. The big three being limit, derivative, and integration. We've talked at length about the limit. This is going to be the 205th video on AP Calculus, but it's going to only be I want to say either the 5th or 6th video on the big three. So our question for this morning is, when do I use a derivative? We've been talking about the types of derivatives. There's the power rule, there's the product rule, there's the quotient rule, and there's the chain rule. And so we've gone through all of those. Now, when do I know that I use them? Well, I need to realize that I'm using the derivative that when I'm trying to determine a rate of change. Okay? And everything that it may be a rate of change. Okay? Kind of like acceleration, from velocity to acceleration. Velocity is a rate of change, but acceleration is a rate of change. So that's what we're talking about here, is a rate of change. Let's talk about this. Now, let's just get into this problem here. Maybe, and this is not in any particular order, maybe we're interested in finding out if a function, so is a function increasing or decreasing? Is a function increasing? That means if I were to look at the xy axis, is the function of f increasing as we move further and further to the right, or is it on the other side? On the other hand, is this function decreasing like that? Okay, maybe from some number a to some number b. Okay, from a to b, is the function increasing or decreasing? Alright, and that's one thing that we can do. Alright, so we may have f as a function. Alright, we want to find out if this function is increasing or decreasing. Alright, let me give you an illustration of that. Let's look at f of x is equal to, let's see, 2x squared minus 5x minus 12. For those of you who, you're being in AP Calculus, you should be able to recognize this as a parabola that curves upward. How do I know it's curving upward? This 2 up here in front is positive. In front of the x squared term, this coefficient is positive. I know it's curving upward, and at some point, see, it starts out decreasing. It gets to a vertex. Okay? Alright? And we're going to get into this later, that's where the slope is 0. But then it starts increasing. So decreasing, and this is probably to the left of some number. X is equal to, say, 2. We'll look at that. Let's look at this right here. let's ask ourselves the question, is f increasing or decreasing? Well, we've got to find out. We've got to take the first, this is called the first derivative, and we're only dealing with first derivatives. We'll get into the reason for a second derivative later. I don't want to confuse us and get us all worked up into the second derivative. And, you know, let's just look at the first derivative. When do you take a first derivative? Not only are we looking at when do we take a derivative as opposed to when we integrate, we're also looking at, you know, when do we take the first derivative? And then later on we'll look at, well, when do we take a second derivative? And that's what we're talking about. Take a first derivative, if you're wanting to look at increasing or decreasing. And again, this is the exponent rule or the power rule. 2 times 2 is 4. X, remember 2 minus 1 is 1, which is, I don't need the 1. If there's a 1 here, 1 times 5 is 5. There is no, it's x to the 0, so just kind of keep that in mind. Derivative of a constant is 0, so we're not going to put 0 down here. This, we're going to find out later, represents the slope of the tangent line to the curve. That is like this. If I and so what we're going to look at is the slope at some number. Okay, well, we're going to also look at, so here's your curve. I don't know what it looks like really. It could be down here, it could be way over here, it could be way over here. I'm sure it's going to be over somewhere. The slope is going to be like this is a slope. A slope here. The line, this is, see, these lines are, okay, tangent means touching the line. So this is a negative slope going this way, but this is a slope of 0, and then all of a sudden the slope of the tangent line is positive right here. Alright. So what we can do is we can find out, so decreasing if the slope is negative, increasing if the slope is positive. We can find out if this, let's look at that. So we're really looking at the slope. Let's say 2. Alright, what does this look like at 2? Well, 4 times 2 is 8, and 8 minus 5 is 3. We're not really concerned what the answer is. We just understand that it is positive, and because the slope is the slope is positive at x equals 2, this means that this graph of f, not f prime, but f is increasing. So f is increasing at x equals 2. Okay, like that. And that's one way to determine. It would be decreasing if we could make this number smaller than 5. We can do that immediately if we set f at 1, f prime at 1 rather. 4 times 1 is 4. 4 minus 5 is negative 1. And again, we're not concerned about the answer. We're just concerned that it's negative. And so that means that f is decreasing at x equals 1. So somewhere between 1 and 2, there is a, what do you call it? A vertex, because it's decreasing at x equals 1, but increasing all of a sudden at x equals 2. Alright, we're not going to go into all that increasing and decreasing, but that's one way. Okay, and we also talked about the slope and so on, but let's look at, real quickly, I want to find the slope of this function here. Alright, the slope of this one is represented by 4x minus 5. Alright. Alright, so another thing is I want to find the slope. Anytime I want to find the slope, I'm going to use the first derivative to find the slope. Alright, so that's one thing I can do. So let's look at y cubed. Oh, wait a minute. Oh, I have not done. Let's not worry about implicit differentiation. So I'm not going to do that yet because it can be difficult. So we can say, let's just make up something then. 3x to the 5th minus 2x to the 4th plus x to the 2nd power. I want to know the slope. Oh, by the way, this is, alright, so if I'm finding the slope, let's put the word slope down here. Alright, we're going to call this function F. F at x equals. So I want the slope of F. So if you see that little mark right there, that's the first derivative. That means I'm looking for the slope, maybe, in the context of what we're talking about here, the slope. So again, 15x to the 4th. Alright, minus 4 times 2 is 8. X to the 3rd. Alright, plus 2 times 1 is 2. X, remember 2 minus 1 is 1, so we don't need it. That is represented the slope right here. This represents the slope of this function F. Alright, it does. Now again, let's just kind of put something simple in there maybe. Alright? And maybe we want to find the slope at, say, -1. Alright, what is the slope of this function? Alright, so 15 times -1 to the 4th minus 8 times -1 cubed plus 2 times -1. -1 to the 4th is 1. Anytime you have an even exponent, that negative goes away. Alright, negative times a negative times a negative times a negative is a positive. So 15 times 1 is 15. Minus 8. Now, -1 times -1 times -1, this is +1 times -1, which is -1. So an odd will make this negative, but so this is -1 here, and then 2 times -1 is -2. Alright, so 15 plus 8 minus a negative is plus 8 minus 2. That's 23 minus 2, 21. The answer is positive. So my question to you is, not only did we find the slope, but the slope, wow, at x is equal to -1, that slope is real steep. 21, isn't it? Real steep slope, isn't it? Almost straight up and down. But, is this function increasing or decreasing? Well, it's positive, so it is increasing. At x equals -1, it is definitely shooting up real sharply upward. Even though we don't see the graph, we know that it's shooting up sharply because we see that the slope at x equals -1 is 21. That's what the slope is right here. Okay? The slope is not -1. We're looking at -1. What's the slope? Of the tangent line to the curve is 21. Very sharp slope. See, 1 is like this. So 21 is going to be way It's going to be way up like that. Real sharp slope. Almost straight up and down. You know. But anyway, so this graph, the graph of F, is increasing at x equals -1. The slope is 21. The graph is increasing at x equals -1. So there we have it. We'll look at the next time we're going to look at slope probably. I want us to get into implicit differentiation, and we'll do it. Well, I do want to give you an implicit type problem, and also related rates. Also, when a particle is in motion, I want to get into all that, and then we'll get into the second derivative later on. But anyway, this is KP the Math G, getting ready to sign off. My wife has made it home, and today's Sunday. It's time to eat, and so I look like I need to eat, don't I? Okay, bad joke. Anyway, please hit that like button. If you do, that just puts a smile on my face just thinking about it. If you'd like to make a comment, please do so. If you'd like to subscribe to this, please do so. But again, whether you do that or not, this is for your benefit, and I guarantee you, knowing that school is starting, and we are in August, by the way, so school is starting very soon, and for some of you it's probably tomorrow. For others in the world it may be Tuesday. Whatever, school's starting soon, and this will get you on the right track. If you're taking AP Calculus, this will get you on the right track. Anyway, this is KP the Math G signing off. Ladies and gentlemen, have a great day.